Every piece of tech you've ever used, the phone in your pocket, the laptop you're watching this on, and the smartwatch on your wrist, they all share one thing in common: a screen. And that is about to end. And no, I'm not talking about VR. There's a technology that is already inside real human brains right now, today. And that is going to change what an interface even means. This is the biggest shift in how humans talk to machines since the mouse. And it terrifies designers because it removes the one thing they spend their most of the time building: a screen. Hello, I'm Moksh and this is Behind Your Screen. But to actually understand why this is such a big deal, we need to zoom out first. Because this isn't some random new gadget. It's the next step in the pattern that's been running since the very first computer. See, the entire history of computing is just one long story, and it's always the same one: getting the machine out of the way. With punch cards, you had to speak the computer's language exactly. One wrong hole, nothing worked. Then the command line came, and you got to type in the words, and then the mouse and the GUI arrived. And suddenly you did not even need to know any language at all. You just pointed at what you wanted, and then in 2007, the biggest one, the iPhone removed even the mouse. Your finger became the pointer. Now your voice has removed the screen from the equation entirely. For the simple stuff, you just say what you want out loud. Every single one of these caused the same effect: shrink the gap between the intent and what actually happens. And you keep following that line all the way to its logical end. There's only one place left for it to go. No pointer or voice or gesture, just the intent itself. Now, before you picture some full sci-fi mind-reading machine, let's ground this into what's actually happening on ground. Because it's less flashy and more real than you would believe. Neuralink has already implanted its device in human patients who can now move a cursor, play chess, control a computer using nothing but thought. Synchron is doing something similar, but through a less invasive method: a stent threaded through a blood vessel instead of an open brain surgery. And the Apple's Vision Pro, while nowhere near a brain interface, it's actually missing the middle step here. It actually reads your eyes as the pointer and your hand as a click. And you can look and then pinch. That's your intent, translated with almost nothing in between. Right now, all of this is scoped to accessibility. People who cannot move or speak, getting back some form of control they've lost. But so was mouse once. Every interface that eventually became universal started out as a niche tool for a small, specific problem. This shift should sort of unsettle designers because that takes away the screen and you take away the layout, take away the pointer, you take away the buttons, colors, hierarchy, spacing, every single tool a designer has used for the last 40 years to tell what you do and where to look. For a second, it feels like the design becomes invisible. But if the machine responds to the intent directly with nothing to click, nothing to arrange, then the whole job is deciding what should actually happen before you even ask for it. Not how a button looks, just is this the right action at the right time for this person specifically? That's the design with absolutely nowhere left to hide. The best interface was always the one you did not notice. A brain-computer interface just makes that literal. And if this feels familiar, it's because we've actually been walking straight towards this exact point already. In this video, we talked about how software is quietly moving away from fixed screens and towards interfaces that gets generated on the spot, built in the real time around what you're trying to do. Instead of you navigating a menu someone designed 6 months ago, a brain-computer interface isn't some separate, unrelated technology. It's the far end of the exact same line. The screen becomes invisible. Every move along this line reduces the distance between what you want and something happening. Scarily, when there's no screen, there's no visible boundary either. No "are you sure" pop-up, no confirmation button, no undo, which means the actual job for whoever builds this isn't making it look good. It's making something invisible feel trustworthy. That's a much harder problem than any button or any screen ever was. For 40 years, we designed the screen, every pixel, every animation, every rounded corner, all in service of one thing: getting out of your way just a little more. And next, we design intent. So I ask you this: if the interface disappears completely, if there's nothing left to click, nothing left to confirm, what's the first thing you would actually want a machine to just do without you asking? And be honest, do you trust it enough to let it do it? I'm Moksh, and I'll see you in the next one.